In this video, we're going to look at example B part B from example 2, where we find asymptotes of a rational function. In part A, hopefully you remember that we found the vertical asymptotes. So in part B, we are going to look for the horizontal asymptotes for the function, or for the graph of f of x equals 3x minus 2 over x squared plus 7x plus 12. The first thing we need to look at when finding horizontal asymptotes is there's three possible scenarios. So we're going to call them case 1, case 2, and case 3. All right, and this is more notes than answering this question, but we need to go through these cases before we're going to be able to find the horizontal asymptotes. So case 1 is when the degree of the numerator is less than the degree of the denominator. And remember, when we're talking in terms of degree, we're talking about the highest power in this case in the numerator and separately in the denominator. So an example of that would be something where we have g of x is equal to x plus 4 over x squared plus 1. And what's going on here is this is to the first power, right? So this x, and this is to the second power. So the degree of the numerator is less than the degree of the denominator, because that 1, right, this is a 1 here, 1 is obviously less than 2. So if that is the case, so when the degree of, whenever the numerator degree is less than the denominator degree, there's a horizontal, almost mixed that up, sorry. There's a horizontal asymptote at y equals 0. Again, this is always the case. So in case 1, anytime the degree of the numerator is less than the degree of the denominator, like our example here, then there is a horizontal asymptote at y equals 0. Okay. So let's go on to case 2. Case 2 is when the degree of the numerator, and we're just going to do the opposite here. The degree of the numerator is greater than the degree of the denominator. And an example of that would be where you had something like g of x is equal to x squared plus 1. So we're kind of just going to flip this. We'll just say x plus 2. And now we're again looking at the highest powers in each piece, and we can clearly see that the numerator has a degree of 2, the denominator is a degree of 1, 2 is greater than 1. So if this is the case, there are no horizontal asymptotes. All right, so if the numerator degree is higher than the denominator degree, then there are no horizontal asymptotes. That would be case 2. And if you're kind of following along, you should figure out, you should be able to kind of guess what case 3 is. Case 3 is when the degree, can't spell here, when the degree of the numerator is the same as the degree of the denominator. And an example of that might be something like, let's say g of x equals 2x squared plus x plus 1 over, let's say x squared minus 1. I'll keep it simple. And now we can see that they're both second degrees. The numerator and the denominator have the same degree. So when this is the case, then the horizontal asymptote the horizontal asymptote, there we go, let's spell that correctly, is the ratio of the leading coefficients. All right, now what does that mean? What that means is that we look at the leading coefficients for the highest degrees. So this would be a 1, right? So in this case, we have 2 as leading coefficient in the numerator and a 1 as the leading coefficient in the denominator. So what that tells me for this specific problem, my horizontal asymptote I don't know what I'm trying to spell, I'm having trouble spelling today, would be y is equal to, in this case, 2 over 1, but we can just change that and we can just say y is equal to 2. But it's important to note that these numbers here are coming from the leading coefficients of the highest degree powers from the numerator and from the denominator. Okay, so these are your 3 cases. Case 1 is where the numerator is less than the degree of the denominator. That you'll have a horizontal asymptote of y equals 0. Case 2 is the easiest one because if the numerator degree is higher than the denominator degree, you don't even have to worry about a horizontal asymptote. And case 3 is the one where you have to be the most careful because if the degrees are equal to each other, numerator, denominator, then you need the ratio of the leading coefficients. Okay, so all that tells us is that just gives us the cases, case 1, case 2, case 3. But our question is, what is the horizontal asymptotes for the graph f of x equals 3x minus 2 over x squared plus 7x plus 12. All right, so I'm going to look at the leading terms, or sorry, not the leading terms, the highest degrees. And my numerator is a 1, my denominator is a 2. So what that tells me is that the degree of the numerator is less than the degree of the denominator, and less than is case 1. So that's a case 1 example. You don't really need to write cases when you're doing these problems, but I'm just referencing back to this chart. So since it's case 1, that tells me that there is a horizontal asymptote at y equals 0. Right, and that answers our question. And if you go back to example part A, or example 2 part A, you'll see that when we kind of drew this graph, this sketch of this graph based on our Desmos or graphing calculator, you can kind of see that it approaches that y equals 0 but never actually touches it. And that's where you wind up with that horizontal asymptote. So it's really, really close to y equals 0, but again, it will never actually touch. All right, so that's example B. I would highly recommend making sure you have access and availability to this case 1, case 2, case 3 chart. Always reference back to those until you get quite familiar with the setup and then each scenario, and you'll be in pretty good shape. These ones generally aren't too bad. The horizontal asymptotes usually are easier than the vertical asymptotes. The vertical asymptotes, there's some factoring involved. There's some scenarios where you have to be extra careful. But the horizontal asymptotes, you're really just referencing through these cases, and you'll be okay.